A histogram is a plot for showing how numbers are distributed. For example, here's a list of temperature measurements, and here's a plot called a number line plot created using the number line plot function, which plots those measurements as dots along a number line. Number line plots have the advantage of being simple and compact, and number line plots do show basic features of the data. It's easy to see from the number line plot, for example, that the measurements are concentrated near the middle of the range and are more thinly distributed near the edges. It's difficult, however, from a number line plot to see precise features of the distribution, and when there are lots of numbers, there can be so many dots that the dots visually merge together into a continuous line. These issues can be addressed using a histogram. This input uses the histogram function to construct a histogram of that same data. The histogram shows the distribution of the measurements by sorting the measurements into intervals called bins, and then basically making a bar chart of the number of measurements in each bin. Each bin in this example represents 2 degrees of temperature, starting at 22 degrees. The number of temperature measurements in each bin is shown as the height of the bar for that bin. The height of the first bar shows that there are 4 measurements between 22 and 24 degrees. The height of the second bar shows that there are 7 measurements between 24 and 26 degrees, and so on. One of the most important features to control in making a histogram is the width of the bins. The width of the bins can be controlled using the second argument of the histogram function. For example, this shows a histogram for that same data, but with the second argument of histogram used to set the width of the bins to 0.5 degrees. If the second argument is omitted, the histogram function uses general heuristics to choose a default width for the bins. In this example, the default uses bins with a width of 2 degrees. Smaller bins can sometimes be useful for showing more detail in the distribution. The histogram using bins with a width of 0.5 degrees, for example, does show more detail than the default. It is important, however, to avoid choosing bins that are either too small or too large. If the bins are too small, as in this example, there may be only one or a very small number of measurements in each bin, which can give a plot like this one with only one measurement in each bin. This plot is effectively just a number line plot that uses bars along a number line rather than dots. If the bins are too large, as in this example, the histogram does not show enough detail. In common usage, the width of bins is typically chosen to give a histogram with between 5 and 20 bins, but a much larger number of bins can be appropriate if there's enough data. For example, here is the default histogram for a list of 100,000 random numbers using the default bin size, and here is a histogram of that same data but with the bin size set to 1. The default bin size in this example is 20, so the first bar shows that the data includes about 3,000 values between 0 and 20. The second bar shows almost 8,000 values between 20 and 40, and so on. The plot with a bin size of 1 shows considerably more detail for the distribution of the numbers, and depending on the application, this is a reasonable and potentially quite useful alternative.